So yesterday we started to look at cumulative frequency, so we were adding up the totals as we went along, and the day before that we were looking at median and quartiles. So let's just go over to the Google Classroom and have a look at what we're doing today. So here is the classwork for today, and we're basically practicing some of the skills that you have learned over the last 2 days, but doing some work from the textbook. Okay, so let's have a look at these questions. Okay, so exercise 117, questions 1 to 4, and exercise 117 star, question 1. I think I'll probably go through one of those questions with you now, and then we'll have a look at drawing your own cumulative frequency curve. So yesterday on My Maths, you were just having to put the crosses on. Drawing your own one, you're going to have to do all the axes and the scales and everything. Okay, so if you have got a textbook at home, fantastic. If you haven't, then the link for the textbook is in this stream. So you can just go to here. All right, so that takes you to this folder, and the one that we want is this one. Guys, could you turn your microphones off, please? I think someone's is on and it's just making a little bit of noise. Thank you. Okay, so here's our text. Oh, sorry, that's my dog barking because there's someone outside. All right. So hopefully you can open your textbook on the right page. I think I'm going to try and show you the actual textbook and go through a question with you. So I'm going to stop sharing this and I'm going to switch cameras. See if I can get this to work. All right, so hopefully now you can see, once it gets into focus, this bit of paper, and you can see the exercise there. All right, so we are doing exercise 117, questions 1 to 4, and exercise 117 star, question 1. So it's these 5 questions. That's for the first task. All right, so this is just a bit of a recap, a chance to consolidate some of the skills you did before. So I think right now I will go through question 1 just as a reminder. Okay, I'm just going to get a pen. Can you guys also get yourselves a pen and paper and have a go at this question right now? So hopefully you've got your own exercise, your own textbook, or you've got the online version. But if not, you can see the question here. So it says, for questions 1 to 4, find the median, quartiles, range, and interquartile range of the sets of numbers. And we're going to look at this first set, and the numbers there are 3, 6, 8, 2, 4, 3, and 1. Okay, so I'm going to give you a moment now. I'm just going to pause for maybe 1 minute while you get started on that question, and then we'll go through it together. I suggest that you do this in the same place you're going to do your work. So in your maths exercise book, the title for today can just be median, quartiles, and cumulative frequency, because we will be doing one question on that. So this is task 1, and we can say this is an example. All right, like I said, I'm just going to wait a minute for you now to have a think about that before I go through it. Putting the data in order. 1, 2, 3, 4, 5, 6, 7. Good. I've still got 7 bits of data. Okay. So for the median, I can either look from both sides and just find the middle number. That's quite easy with only a few bits of data. Or we can use the formula, which is n plus 1 over 2. So that is 7 plus 1 divided by 2, which is my 4th bit of data. 1, 2, 3, 4. So my median equals 3. And remember the other notation we use for the median is Q2. Okay, now for the lower quartile, which we call Q1, instead of dividing by 2, I divide by 4. So this is the n plus 1 over 4th piece of data, which is 8 divided by 4. So it's my 2nd bit of data. So it's that one. The other way we could do it is, because we found our median, it's an exact number, then I just look at the bottom half of the data and I find the middle one. So that's my Q1. There's 2. For my upper quartile, which is also known as Q3, it's 3 lots of n plus 1 over 4, but if you've already found where the Q1 is, you can just multiply that by 3. So instead of the 2nd, it will be the 6th piece of data. And the other way to do it is to just find the middle of what's left on the top half. So my upper quartile is 6. So just writing those all down together, I've got my lower quartile, my median, and my upper quartile there. The question also asks me to find the interquartile range, which you're allowed to just use IQR for interquartile range. Okay, how do we find the interquartile range? I'm going to pick somebody who's on the chat to tell me how to find the interquartile range. Let's ask Jackie. Jackie, can you turn your mic on, please, and explain how we would find the interquartile range?
I didn't get that.
You didn't get it. Were you in the lesson the other day when we talked about it?
I don't think so.
Okay. In that case, I'm going to ask someone else instead. How about Millie? Millie, do you know how to find the interquartile range?
Is it Q3 minus Q1?
Yeah, perfect. Q3 minus Q1. So it's the upper quartile minus the lower quartile. So for this data, it's going to be 6 minus 2, which is 4. So our IQR is 4. Okay, looking back at the question, it also says, and the median, the quartiles, the range, and the interquartile range. So the range is something that you've done before, we're also asked to find it. So how do we find the range of the data? Natalie, can you tell me how to find the range of my set of data, this data here? Hello, Natalie. Okay, lovely.
I'm not sure.
Not sure. Okay. All right, I'll try someone else then. How about Priyanshu? Do you know how to find the range? Priyanshu, are you there? You're typing. Oh, sorry, I forgot your microphone's broken. Okay, biggest number minus smallest number. Perfect. So it's our highest value minus our lowest value. So we look back at our data. Here is our highest value. It's 8. And our lowest value is 1. and our range is kind of the difference between them. So from 1 to 8, or 8 minus 1, we get 7. So the range for this set of data is 7, and the interquartile range is the distance just between here and here. Okay, so it's just looking at the difference between the middle half of the data, we call that. Okay, so there are our values. That's question 1, and you guys are going to be doing question 2, 3, and 4. Similar method, it's just slightly different numbers. And then for exercise 117, rather than having your data written out as a list, it's in a table, but it's the same. You just got more numbers, and they're given to you in a table. Okay. The other task that's on the agenda for today, first of all, does anyone have any questions about what we've just done? You can shout them out, or you can pop them in the chat. Any questions about the work we've just done? Okay. All right. So let me talk you through the second half, because I think maybe then you guys can just get on. So the second task is doing exercise 118, question 8, part A only, and it's drawing a cumulative frequency curve. So that is a reminder, cumulative frequency curves, they look like this. We do a running total as we go, so we add up the frequencies as we go to get a total. So here we've got 2000, and we plot the points. You can't see crosses here, but you'd have to put down crosses in order to draw it. And question 8 is this one. So it says, the table gives the distribution of lengths of marriages that ended in divorce. Okay, that's a little bit of a depressing subject, but okay. So we have 15 marriages that lasted between 0 and 3 years, 22 marriages from 3 to 5, and so on, all the way up to T is greater than or equal to 30, which we have 9 marriages. And I want you to draw the cumulative frequency table. So you need to copy out this table and draw an extra column in your book that says cumulative frequency, and then do the added totals as we go. Now I've put I think I've made a mistake. I'm going to just change those instructions. I actually want you to do A and B. So then I want you to draw the cumulative frequency curve. Okay. Part C, you may be able to do, if you could remember it from yesterday, estimating the median and the quartiles, but you don't have to do C and you don't have to do D. So guys, right now I'm going to go through an example. I'm going to actually go through how to draw out the cumulative frequency. I'll do it for probably just question 7 because it's here. So I'm going to do that as an example. If you get a choice now, so you can turn the mic off and you can go and work on the first task that we've just been looking at, because I will record this example and then I'll upload it. So then if you need to watch this example back later, you can go to the video that I upload. Bearing in mind it takes a little bit of time to upload, so it might not be ready the moment that you need it. So it's up to you now. You can stay and you can watch me do this example, or you can get cracking with task 1 and you can watch this example video back later. But I'm going to do this question now as an example. You guys are going to do question 8, part A and B. Okay. So get my new piece of paper. Let me just check that you guys can see. Okay, so this is question 7, on page 286. And to start off, I'm just going to copy out the table. So this question is about weights of babies born in a city hospital. So we've got 55 babies and they're measured in kilograms. And so I'll put n equals 55 because it tells me that in the question. And then I use W to represent the weight. I've got babies that are less than 1.5 but more than 1.0. So I've got nothing that's less than 1 kilo for this data. It's not to say that it's impossible to have babies less than 1 kilo, but out of these 55, we didn't have any that were less than 1. We had 2 that were between 1 and 1.5. So all I'm doing is copying out the question, but also just having a think about the question at the same time. So this is 1.5 to 2. And I need to go all the way up so that this column goes up to 4.5, where we just have babies more than 4.5. So that this bit's blank here, but it's not a mistake. It's just that this final row represents all babies that were more than 4.5. The W means weight. And you can see here, this one says less than or equal to, this one says less than, which means if I've got a baby that's exactly on the boundary, so a baby that's exactly 1.5, it would go here. If I had a baby that was exactly 3, it would go here. Okay, it goes into the class above. And frequencies, again, I'm just copying these out from the book. 2, 7, 10, 14, 9, 8, 5, and then none that were above. And my total, if I add all of these up, is 55. Okay, I know that it's going to be 55 because I'm told there's 55 babies, and it will be a good check in a moment when we do our cumulative frequency, because this final box here should be 55 if I've done it right. It's a nice way to check. Okay, CF, which stands for cumulative frequency. So now I'm doing my running total. So the first row is always just the same. I've got 2. Now I add on the next 7, so my total is 9. Add on the next 10, so my total is 19. And I add on the next 14, so my total is 33. I add on the next 9 to get 42. Add on 8 to get 50. Add on 5 to get 55. And then add on 0 to get 55. Okay, so this is a good sign, because if I got something other than 55, I know I've gone wrong somewhere with my adding. All right, so that's part A done. I've constructed my cumulative frequency table. And part B, I need to do cumulative frequency curve. Okay, so it's called a cumulative frequency curve, or sometimes a cumulative frequency graph. My version of this graph is going to be a little bit rougher than yours because I actually don't have a ruler. So I'm just going to draw it by hand, but I do expect you guys to draw yours out with a ruler, kind of doing it properly. So the cumulative frequency is always up the side. Okay, so that's my cumulative frequency, and I know that I need to go from 0 up all the way up to 55. That's my minimum and maximum there. So I'm going to go up in 5s. I'll do 5, 10, 15, 20, 25, 30, 35, 40, 45, whoops, 50, 55. Okay, that wasn't quite perfect, but really we should measure out in advance and use the squares. Okay, so there I've got my cumulative frequency scale. Along the bottom, I've got the weights, and although we don't start from 0, we start close enough to 0 that I'm just going to going to put 0 as my starting point, and I need to go up to, I'll go up to 4.5. So 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. And I'll pop those numbers in. Oops, sorry, you couldn't see that. Okay, now this is a lot easier to do if you have squares. I don't have squares. I can sort of see a bit of a grid that's printed on the back that's actually a register. All right, now I'm going to plot using the top end of my cumulative frequency curve as my x coordinates. It's going to be my x coordinate. We always use the top end. That's important to remember for cumulative frequency. And then I use these ones as my y coordinates. So my first point will be 1.5 and 2. And actually I could also include here 1 and 0, because I know up to 1 I've got nothing. Okay, so that's kind of my starting point, 1. Then 1.5 would be 2. 2, a weight of 2 kilograms, I've got 9. Weight of 2.5 kilograms, I've got 19. So I'm just doing my best here to kind of measure it out. 3 kilograms, I've got 33. 3.5 kilograms, I've got 42. 4 kilograms, I've got 55. And then that's really the end, but I could pop in this one as well because I know I've got no more. They're both the same level. They're both 4.5. I'm sorry, they're both 55. I go along there. And the final thing for me to do is join those up with a smooth curve going through every point that I can. Okay, and then it will be flat at the end there. Okay, right, I'm going to stop there. That's the example, and I want you guys to have a go at doing, like I said, question 8, parts A and B by yourselves, and if you want to have a go at parts C and D, you can. And the only other last thing was I did give an extension question on there as well. Let's just get back to normal camera. There we go. So the extension question was, just share my screen with you. Also to finish exercise 117 star, so the rest of those questions. And I'll pop in there also part C and D for exercise 118. Okay, right guys, I'm gonna stop recording now.